you also have a brand new open source product, which is called Phoenix. So tell us about Phoenix. Can it do everything that the Arize Enterprise product can do, for example?
Yeah, so Phoenix is bringing part of the functionality of the Arize Enterprise platform, which is the SaaS platform. It's bringing part of that functionality into a notebook environment. So what it actually is an application that runs alongside your Jupyter notebook, runs on the same server that's running your notebook server, whether that's your local computer, whether that is your collab server, and it actually gives you this interactive experience that's more immediate than uploading data to a SaaS platform. And right now, at the moment, it's really focused on unstructured data, on the unstructured offering that I talked about a moment ago. But I think in terms of the long-term scope, we're really trying to be responsive to the community. What does the community want? What is the community hungry for? And right now, the answer is they're really hungry for LLMs. So that's really like where the push is happening for us on the Phoenix front right now.
Awesome. Yeah. So, I mean, tying back in perfectly to a lot of podcast episodes that we've had recently on the show, we've had a lot on generative AI, on large language models. Obviously, like my talk at ODS East was focused on that. It was a super popular one. And I knew it would be because this is just like what everyone's talking about, whether you're in data science or not, and whether you know to call it large language models or you know to call it generative AI, everybody's talking about ChatGPT, GPT-4, Midjourney, and how these large language models are impacting the world, and is my job safe, or like how is this going to change things in the future, what are the policy implications, what does this mean for misinformation. So yeah, so like one way or another in the data science world or not, these are major topics. And so it's really cool that you have decided to go to be kind of LLM first, unstructured data first, with your Phoenix open source product. So yeah, so I mean, is this something like people just go to the GitHub repo and it's like straightforward how to be using this with your LLMs?
Yeah. So you can just pip install it. It's pip install Arize-Phoenix. You can check out our GitHub repo. You can check out our docs. We got a bunch of tutorial notebooks up. Um, yeah, so it's free to get started. Just put it in your notebook and run it.
Nice. And then like, are there additional kind of resource requirements? Like I guess if we already have so typically to be running an LLM, we'd need to have some pretty big infrastructure running, probably with at least one GPU. And then so I guess in addition to that, there's probably no additional like infrastructure requirements. It'll be relatively lightweight relative to the model.
Yeah, there's no infra requirements at all. You can run it along, if you're running in a notebook environment that has like a GPU, you can run it there, but you don't need a GPU in order to run the app.
Of
The
course, of
app is
course.
just this pretty lightweight application, and it actually is going to be a UI that you can actually use either in a separate browser tab, or literally you can open up the UI and use the application literally inside of the Jupyter notebook.
Gotcha. So once you get Phoenix running,
Mhm.
that yeah, it allows you similarly to the way that you might have Tensor board running
Yep.
for
Yep.
watching your machine learning model train. Whether Tensor board comes originally from TensorFlow, but your model could be in PyTorch. It doesn't matter. With Tensor board, you can open up another browser tab, or again, you could have it running just there in the notebook, and you can watch your model's cost hopefully go down as your model trains. And so similarly, you could have another tab open with Phoenix running, and
Mhm.
so you could be watching in real time as your model's running in production. Just have this extra tab open, and then that sounds like ML monitoring to me so far.
Mhm. Mhm.
So, but Phoenix also has built in like the observability component that if we hit that, to go back to the financial algorithm, if we hit that stop order price, we'll end up triggering alerts.
Oh yeah. Oh yeah. So one thing I'll say is like Phoenix at the moment is not real time. If the community, if we find that the community wants
Oh,
that,
gotcha,
we could put that in.
gotcha.
But at the moment, it's not a real time application. That would be the SaaS platform, right? But imagine that you've got some inference data, right? And imagine that we're in this situation where we want to detect drift. And before I mentioned, you're monitoring your embedding distribution, right? And we're able to actually measure quantitatively how far has the production distribution drifted away from the training distribution of embeddings? And so you can imagine you've got like this graph showing you drift of your production data relative to your training data over time. Again, all of this is the drift of the embedding distribution, right? And then what we can do is like we can take those embeddings, and this is where I wish I could show the people who are listening. But imagine this: like imagine you take the embeddings, which are these high dimensional vectors, right? They could be 1,000 dimensions or more, right? And you take those embeddings and you do some dimensionality reduction to view them in 3 dimensions. So now you're actually literally able to see your two embedding distributions in 3 dimensions, your production and your training distributions. And again, like I mentioned, like if the production distribution has shifted away, has drifted away from that training distribution, again, you're going to be seeing pockets of production data that you didn't see during training. So it's really cool. You can like literally see the exact data points in production where you didn't have training data. And
Gotcha.
then what we do is we provide this. Yeah, go ahead.
But this is all Phoenix that you're still describing, right?
So this is Phoenix, but this is also in the SaaS platform.
But so like this is gonna sound I must like have missed something. But so you said Phoenix doesn't work on production, but everything that you were just describing was like production
Mhm.
embeddings and comparing those to training. So like yeah, so like I don't so like when we're watching Phoenix, when we have this extra tab open as we're training, like what are we watching? Like what are we like you were talking about it as like comparing production embeddings
Yeah,
versus training embeddings, but
yeah.
like I wouldn't have like if we're just training a model, what does production embeddings mean in that context?
Yeah. So I think I was probably I was just trying to say like it's not I was trying to clarify like Phoenix isn't an app that you're like logging real-time data to, if that makes sense. It would be like imagine you've got
batches of production data. So
yeah.
you can still have batches.
Oh,
Yeah.
I see. So
Yeah, yeah.
okay. So I
Yeah.
completely misunderstood. So I was thinking that Phoenix was like I was then now like okay, I have two tabs open. I've got my tensor board running, and maybe this is like it's my mistake because I like was just kind of like running with this idea. But like I'm training a model in my Jupyter notebook, and I've got a tab open that I'm watching like my loss functions on, and then I've got another one where I'm watching Phoenix. But that isn't what you'd be
Not quite.
doing.
Not quite.
You're
Yeah.
taking batches of production data
Mhm.
and ad hoc looking at them to check for drift.
Mhm.
So Phoenix allows you to do ad hoc ML monitoring to
Mhm.
identify like your own issues and to see like to give you a better understanding of maybe where your model's starting to fall down in production or where it has limitations and where you might want to be retraining or adjusting aspects of your model architecture.
And
That is an accurate description. Yeah.
yeah, and John, you can also use like a validation set versus a training set. You can use it pre-production, but most folks are concerned with that post-production workflow.
Right.
Even if the inferences are kind of like mock data, most of the time it's like you get a little bit of data back. You're kind of A/B testing. You're getting some information back just to see how well your model is doing. um right, we're not just like validating the model, we're validating how well our model is doing with our customers.
I
Yeah.
gotcha. I gotcha. And so, yeah, and so you made a really interesting example there, Amber, that I hadn't thought of, which is splitting our training and validation sets. So, um, I'm guessing you can correct me where I'm wrong here, but it sounds to me like when we are training our models and we want to make sure that our model works well on data that it hasn't seen before, we have this validation data set that we set aside. But that validation data set is only useful if it matches our training data in terms of obviously not being identical data points, but having the same kind of distribution in the case of structured numeric data or the same kind of embeddings in the case of unstructured data. Yeah, I got some head nods, which only our video version actually, and my head would have been on screen, so you couldn't even see. But Xander and Amber both nodded their heads in agreement at the same time. So okay, cool.
And
Yeah, that's another use
yeah.
case that I hadn't thought of.
And I would just add on to that, right? Like I think I started out with this idea of training versus production because I think that's a lot of the time the easiest one to understand the very first time. But in general, Phoenix is this pretty general tool for being able to diff embedding distributions, right? So as you mentioned, you could be diffing the distributions between training and validation data. You could be diffing the two distributions between a fine-tuned and a pre-trained model. You could be, um, we're getting into like actually really interesting applications right now. So actually, what I've been working on the past couple of weeks is diffing the distribution of embeddings for a context retrieval knowledge base versus the distribution of user queries to understand, are users asking my llama index service or my langchain semantic retrieval service, are they asking questions of my database that are answered in the database or that aren't answered, right? So it's a pretty general idea. It's like really like champion challenger. Anytime you would want to diff to embedding distributions, I would say.
Nice. Great. Thank you for like generalizing this concept as well
Yeah,
as then
yeah,
giving specific examples. Very cool. So yeah. So the canonical thing that we're thinking of with ML observability in general, because this is the thing that we're worried about most in production, is comparing training data distributions versus production.
yeah,
But of course, a tool like Phoenix, which is open source, which we can use for comparing any kinds of embeddings, we can be using that for comparing our training data versus validation data, fine-tuned model versus not. Particular user use cases, making sure that trying to see whether users are kind of using our platform in the way that we anticipated, the way that we trained it for. Super cool. All right.
yeah.
I'm starting to see a huge amount of value here in Phoenix. And so I guess maybe so you mentioned how you developed Phoenix on the one hand because LLMs are so popular today, but I just had a bit of a brainwave, and you can correct me if I'm wrong on this, but it seems to me like that it might also be particularly useful because of how for comparing embeddings, this is so much more complicated than just comparing distributions. So it also kind of seems like you've created a product that solves like the more complex problem. With respect to we talked at the beginning of the episode about like structured data where we're just comparing distributions versus unstructured data where we're comparing embeddings. It seems to me like that latter problem is more complicated, and so this Phoenix problem like scratches that complex itch.
I think that's a good description. And then I think one last thing I would tack on there too is again like the thing that we're really aiming to do is not only detect like that something's changed, but is really to immediately drill down into exactly what has changed. Um, so like what that looks like in the product is uh, we're actually like pointing out the exact portions, the exact embeddings, the exact data points that are causing the drift or that are causing this change in the distribution, and then surfacing those up to the user and telling you this is what you need. This is the data that you need to look at in order to understand why you're experiencing this drift issue, or in order to understand why are the users who are asking questions of my, you know, my semantic retrieval LangChain service, why are they not getting answered, right? Um, that's the idea.